Welcome to the deep dive. We get straight to the heart of things, and today, well, we're looking at something really crucial in aviation safety. The flight data recorder, the black box, it's changing, moving towards cloud integration.
Yeah, exactly. It's been the go-to for figuring out accidents for decades, hasn't it?
Right.
But its limits really hit home with things like the disappearance of Malaysia Airlines MH370.
That's right. Not being able to get that data back, it showed a real problem. And that's what's pushing this idea of cloud integrated flight data recorders, or CIFDR. The concept is basically streaming flight data constantly to the cloud so you don't risk losing the physical box.
And that's what we're digging into today, this whole evolution, from the very first designs to these cutting-edge cloud ideas.
We'll look at the tech making it possible, the hurdles, technical, security, and, well, what it means for the future of flying safely.
Yeah, we've pulled together insights from technical journals, industry reports, market analyses, quite a range, really, just to give you the clearest picture we can.
Okay, let's jump in. Where did this whole idea of a flight recorder even start? It's got a bit of history, right?
It does, yeah. Goes back to David Warren, 1956.
Yeah.
And back then, it was pretty basic.
How basic?
Like only 4 hours of cockpit audio and just a few instrument readings.
Just 4 hours. Wow. Hard to imagine now. And the box itself, people have a certain image, don't they? That orange thing.
Oh, yeah. They're built tough, painted bright orange or yellow so you can actually spot them in wreckage,
Right.
and usually stuck in the tail section, which tends to survive crashes better. For a long time, they used magnetic tape inside.
Magnetic tape. Feels ancient now. Robust, I guess, but probably had limitations.
Oh, definitely. The big leap forward came in the 80s. That's when solid-state recorders arrived.
Ah, so no moving parts.
Exactly. Much bigger capacity, way more resistant to crashes and fire, just more reliable overall.
Okay.
Then around 2007, people started seriously thinking about cloud platforms. Airbus was actually one of the early ones testing it out.
Right, so moving beyond just a tougher box to maybe no box needed on site, what really pushed that cloud idea?
Well, the big problem was always investigating crashes, where the box was just gone, lost at sea, destroyed.
Like MH370.
Precisely. Mark Rosinger, he used to chair the U.S. NTSB. He really pushed for a cloud-based system. He often brought up the Air France crash in 2009.
Oh, the one in the Atlantic?
Yeah. Finding those recorders took ages, cost a fortune. It just hammered home the limits of relying solely on recovering a physical box.
Right, that recovery was a huge effort. So CIFDR aims to fix that. The data's just on it elsewhere, in the cloud, while the plane's still flying.
That's the core idea. You still have the CVR for voice and the FDR for data, but the game changer is that continuous real-time storage in the cloud.
So it's constantly uploading everything. Speed, altitude, pilot inputs.
All the vital stuff. Speed, altitude, temperatures, what the pilots are doing. And there's even talk of adding video feeds.
Video? From where?
Potentially multiple spots. Cockpit, maybe undercarriage, wings.
Wow, that's a ton of data. Why capture all that?
Well, the potential upsides are huge. Imagine ground stations seeing exactly what's happening on a flight in real time.
Faster emergency response.
Much faster.
Yeah.
And this is more controversial, but there's even the possibility maybe of remotely controlling the plane if the crew somehow couldn't.
Remote control. Okay, that sounds intense. But the main thing is the data itself is safe, right? Almost zero risk of losing it.
That's the fundamental advantage, yeah. No more data loss or destruction worry. And think beyond crashes, hijackings, medical emergencies.
Ah, ground teams would have instant info.
Exactly. Crucial information right when they need it to help make decisions.
Okay, so how does all this data actually get from, 35,000 feet up into the cloud? It's not like Wi-Fi is always great up there.
True. It's mainly via satellite or wirelessly to ground stations. Depends where the plane is.
Okay.
If it's near land with an ATC range, it can use VHF, very high frequency. But out over the ocean, then it uses something called a satellite data unit, an SDU. It beams the data up to a satellite. This might use VHF sometimes, but also potentially HF, high frequency, via the satellite for those long stretches, though HF is generally slower.
Got it. Satellites are key. But sending all that critical data wirelessly, security must be a massive concern. How do you protect it?
Oh, absolute paramount. You need basically 3 things. Confidentiality, only the right people see it. Authentication, proving the data hasn't been messed with. And strong encryption, scrambling it so unauthorized folks can't read it.
And that's not just for the cloud storage, right? It has to be secure while it's being sent.
Precisely. You need protection during transmission, too. Things like IPsec protocols help secure the data pipe. And then you have encryption at the application level, like within the databases in the cloud.
So layers of security.
Yeah, and a common approach is just encrypting everything equally. Don't try to guess what's more or less important, just lock it all down. Because if you misjudge, you create a weak spot.
Makes sense. And I've heard the term zero-knowledge encryption thrown around. What's that about?
That's a really strong model. Basically, the airline or whoever owns the data holds the encryption keys. They never give them to the cloud provider.
So the cloud company stores the data, but they literally can't read it.
Exactly. They just see encrypted gibberish. Only the data owner can unlock it.
Okay, that sounds incredibly secure. But building all this, the physical recorder, the transmission, the software, it sounds like a huge engineering headache. What are the big challenges?
You're spot on. It's complex. First, just the physical box itself, even if it's mainly transmitting, the design, the materials, it still needs to be incredibly tough.
Able to survive a crash, basically.
Able to survive almost anything. Huge stress, strain, crazy temperatures, pressure, being underwater, the works.
Wow. What about the guts, the electronics inside?
Storage is key. You need drives that can write data super fast, handle massive amounts of it continuously, and not overheat. That's a big one. And the operating system inside has to be really smart and efficient. It's handling huge data volumes, sharing it in real time, especially for what we call real-time embedded systems, RTES.
RTS, what's that?
Think of systems that need instant responses, like flight controls, critical warnings, stuff that can't lag.
Yeah.
The CI50R's OS needs to manage all that data without interfering with those time-critical functions.
Okay, got it. Needs to be fast and reliable. What about power? Can't have it dying mid-flight.
Nope. Need a reliable main power source, obviously, but also really durable backup batteries. Long life, able to keep things running if the main power cuts out in an emergency.
And the little pingers, the locator beacons.
So need those, especially for underwater recovery. And they need to transmit on both low and high frequencies to give search teams the best chance of finding the wreckage. Vital for recovery efforts.
So super resilient hardware, smart software, reliable power. Quite the package. But you mentioned bandwidth limits earlier. Is sending all that data in real time still a problem?
It is, yeah. Current bandwidth is a bottleneck for transmitting everything instantly. It's improving, though, with cloud tech and IoT advancements. But it's a hurdle.
And the security stuff.
Still a major focus. Plus, honestly, there isn't really a perfect off-the-shelf cloud platform built specifically for aviation's unique needs yet. It's still evolving.
Okay, so CIFDR is the big goal, but it's not quite here yet universally.
Yeah.
Are there other ideas being looked at in the meantime? Sort of bridging solutions?
There are, yeah. One's pretty straightforward. Just put 2 black boxes on a plane.
Like a backup?
Kinda. Maybe one standard protected memory type and another that's designed to be ejected or deployed automatically in a crash. Makes it easier to find, potentially. Airbus was looking into that for the A350 a few years back.
Makes sense. 2 chances are better than 1. Anything more exotic?
Well, there's this really interesting idea using tiny sensors, hundreds of them, embedded right into the plane structure.
Inside the wings and fuselage?
Yeah, creating a wireless sensor network, or WSN. The theory is, even if the plane breaks up badly, you could potentially retrieve data from almost any piece of wreckage.
How?
Using something called probabilistic flooding. It's like the data tries to spread itself out through the network, sensor to sensor. So even if parts are destroyed, the data might survive elsewhere. They call it communicating materials.
Communicating materials? Wow. That's pretty futuristic.
It is. And another area is blockchain, using that distributed ledger technology to create a totally tamper-proof log of flight data, secure, anonymous event recording.
Blockchain for flight data emphasizes how critical trust and integrity are here. Seems like there's tons of innovation happening, and it's not just about the black box, is it? Cloud computing is like everywhere in aviation now.
Oh, absolutely. The whole aviation analytics market is booming. Expected to hit over, what, $4 billion by 2028?
Wow.
And funny enough, the whole strategic rethink after the pandemic actually sped up cloud adoption in aviation. More demand, new companies jumping in.
So airlines are using the cloud for what kinds of things?
All sorts. Basic data storage, obviously, but also sales and marketing, CRM, customer relationship management, tracking flights and assets, even managing staff schedules. It's touching almost everything.
Really integrating into operations.
Yeah. And it's interesting. A lot of airlines see cloud as a good option for air-to-ground communication, though some still worry if it's completely tamper-proof.
Okay.
Which is partly why you see a trend towards private cloud solutions, More control, maybe better for meeting strict security and regulatory rules.
And the big tech players are involved?
For sure, AWS, Google, IBM, Accenture, they're all deep in the aviation cloud market. And you see partnerships forming, like Megaport working with Lufthansa Systems on their global aviation cloud.
So it's airlines, but also the manufacturers. Aerospace and defense?
Definitely. Boeing's using cloud analytics to give pilots better advice on control adjustments based on flight data. Airbus is using it to streamline how maintenance data flows through their whole supply chain. American Airlines manages asset records in the cloud. The potential efficiency gains are talked about as being huge, like maybe 50% better development, testing, production.
50%, that's massive.
Yeah. Things like using cloud-based robotics, RPA, to speed up making prototypes, using collaboration tools in the cloud to finalize electrical designs faster, even cutting down on physical test flights by using sophisticated cloud simulations.
Like Bombardier did with the C-Series.
Exactly. Saved a lot of money.
Hmm.
And the amount projected to be spent on data analytics, both commercial and defense aviation, it's just going up and up. Cloud infrastructure, applications, it's all growing.
Where are the big focus areas for that spending?
Things like automating the supply chain, predictive maintenance, which is huge immersive training for pilots and crew, even using neural networks to automatically detect damage on aircraft.
Okay, you mentioned predictive maintenance. That seems like a really key application for all this data and cloud power.
It absolutely is. Predictive maintenance is all about using that constant stream of data from the aircraft, running it through clever analytics to predict when a part might fail before it actually does.
So you fix it proactively.
Exactly. Yeah. The goal is less unscheduled downtime, more reliable planes, and ultimately safer flights.
How does it work, technically? What's involved?
Well, you need sensors all over the plane collecting data, temperature, pressure, vibration, fluid levels, you name it.
Yeah.
Engine health monitoring systems are crucial.
Right.
Then that data gets fed into analysis platforms, often using machine learning algorithms, to spot patterns the humans might miss subtle signs of wear or potential failure. And you need good maintenance systems to actually act on those predictions.
Identifying problems before they ground a plane, or worse, happen in flight, the benefits must be pretty clear.
Oh, yeah. Big safety improvements, obviously.
Yeah.
Better operational efficiency, fewer delays, fewer cancellations because of unexpected mechanical issues, and cost savings, less emergency maintenance, maybe extending the life of expensive parts.
Are airlines actually seeing these benefits?
Definitely. Delta, for instance, has talked about significantly reducing unscheduled engine removals using these techniques. And you have major platforms like Boeing's Analyt X and Airbus's Skywise that are really driving this across the industry.
So it's quite a journey from, those first few hours on magnetic tape to potentially having this constant stream of data in the cloud, powering things like predictive maintenance. A massive evolution.
It really is. This whole shift towards cloud-integrated systems, it holds so much promise for making aviation safer, more efficient, and maybe even cheaper in the long run.
But like we talked about, there are still hurdles, big ones. Security is always going to be top of mind.
Absolutely.
And just developing the tech, getting the bandwidth, setting industry standards. Lots still to do.
For sure. These are complex challenges. It needs ongoing work, collaboration between everyone involved, manufacturers, airlines, regulators, and just careful thought.
Okay, so here's something to think about as we wrap up. As our skies get more and more connected, more data rich, could this continuous cloud analysis go beyond just figuring out why something went wrong? Could it actually start actively predicting and preventing incidents before they even have a chance to happen? Are we heading towards like an unprecedented era of air safety powered by data? It really makes you consider the implications, doesn't it?